to that, you have seen depth means what does it mean? That is what you have to see. Okay. Depth means there are two ways we can define the factors affecting the liquid pressure. The first factor, so can you write the first factor you have written depth, correct? First factor you have depth. What do you mean by depth? Depth actually it is equal to height of the liquid column. Depth means it is actually height of the liquid column. Liquid column is in particular.
We have to write after hydraulic pressure, right?
Oh, okay. Yes.
This I have written.
Have you written?
Yes, ma'am. Pressure of.
No, ma'am.
Did you write these
show?
points? Did you write these points? 1 minute. Because I also has forgotten because other two classes over. So I was wondering you are in which part of the lesson you are here. That's why I am asking
Ma'am,
you.
you take till pressure increase with the depth. Only
Ma'am,
that.
can you show the slides after hydraulic pressure and hydrostatic pressure?
Okay. This is the hydrostatic pressure. Have you seen this? Here I have given you note of hydraulic and hydrostatic pressure. Okay. After that, the next slide is this. Have you written any of these points?
No, ma'am.
Okay. 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 Fine. So that's why I'm asking you. So we are moving on to next. First point, what did you write? Pressure increases with the depth. Depth. There, bracket, please write depth means height of liquid column. Height of liquid column. Okay. So that is the first feature. Height of liquid column. That is the first feature. Yes.
Last verse you have given the science. The deeper into it.
Yes. Yeah. I'm going to that point. So did you write height of the liquid column?
Yes, ma'am.
Yes. So on the basis of this, we are having here a slide. Pressure increases with depth means it is also height of the liquid column. So I repeat once again for your memory. So deeper into a liquid you go, the greater the weight of the liquid above and higher pressure. Weight means force. Okay. So as you look at in this picture, you will able to see there are, let us give 3 points A, B and C. A is the first hole, B is the second hole, C is the third hole. Correct? Okay. Now, my question to Adityan. Adityan, my question is, from this A, B and C, from which hole more water comes out? Or
C.
The water, C. So, this is our C. Then after that, which one? So, this is, yeah.
B.
So, yeah. So, this is C. Then come to B. Then go to A. Now, from this, which hole gives you higher pressure?
C.
Is it C? So that means, what do you mean by the height of the liquid column? Depth, I also told it also known as height of the liquid column. So this is the C. So up to here, this much liquid is there. So in a container, if you just take some part of the liquid, we call it in physics column, liquid column. Similarly, if it is air, then also we will tell air column. So if you look at here, the pressure experienced by C is more. One, it is the C is the point at depth, or more liquid is exerting on point C. Now you look at B. As you go top, you will feel that, and on B only this much liquid is exerting. So
pressure is less.
So pressure is less. And why pressure is less? At this point B,
Small amount of water.
small amount of liquid. And when you go to the next point, A. So look at A. Now A is having very less amount of water than C and B. So it also experience very less pressure. So that what we can say, what, how can we, 1 minute, it's gone.
Deeper it go, the pressure.
The deeper it go, the pressure increase. So from this, what do you understand from here? At depth, so from this picture, you can see at C, more pressure. At C, more pressure. At B, less pressure. And at A, least pressure. Okay, that means very much less. Okay, so that's the first point. Pressure depends upon depth or height of the liquid column. Suppose in the case of air, we will call height of air column. Okay, so pressure in liquids, it is also applicable for pressure in fluids also, pressure in gas also. That's why we are talking, but we are discussing more in detail on in the form of liquid, because liquid is more visible to us. Air is not much visible to us. Okay, so did you get that point, children? Next point. Yeah, now this is the second point. So first point, pressure increases with depth or height of the liquid column. So which object experience more liquid, it will experience more pressure. Which object experience less liquid, it will experience less pressure. So that is the difference between the solid pressure and liquid pressure. The next important point, liquid pressure on the bottom of the container does not depend upon the area. Why it's moving? Previous slide. Yes, it is here. So liquid pressure on the bottom of the container depend on the area of the depend on the area. What do you mean by does not depend? In the previous, when we talk about the solid pressure, pressure on wood, pressure on a person, by an object, if that area was a factor. But in the case of liquid pressure, area is not a factor. Here first factor is depth or height of the liquid column. So here, liquid pressure does not depend on the bottom of the container or does not depend upon the area of the container. How much area it is. It is only matters is how much liquid it contains, not the area. Second point, third point, liquid pressure at any point inside the liquid depends upon the density. So height already we have discussed, so you don't have to write that one. You can only write up to here. So already in the note it is there, but still you can go to liquid pressure at any point inside the liquid depends upon the density. Density means,
ma'am.
Hello, yes.
Ma'am, there was a clock.
That I closed it. That is here. My shawl must have touched any one of the things. That's why. Okay, there are so many bars are here. Okay. So next, liquid's pressure at any point inside the liquid depends upon the density. Density means oil and the water. Now tell me, if you put the oil inside the water, which will float? Oil or water?
Oil.
So who is having more density there?
Water.
Water has a more density. So higher the density, higher the pressure. Higher the density, higher the pressure. So oil may not exert much pressure, but who will exert more pressure? Water. So higher the density, higher the pressure in liquids, as well as in the air also, in the gases also. Higher the density of the air, higher the pressure. So they are directly proportional. So height of liquid column is directly proportional, depth is directly proportional, and density also directly proportional. So more denser the liquid, higher the pressure. Got it? So these are the two factors, and it does not depend upon area. Area is not a factor here. Now, the fourth point, how does liquid exert? You see, when we discuss about wooden block and all, where we apply the force, only that particular point pressure experience. But in the liquid, it is not like that. Liquid exert sideways pressure. That means how much water it contains. Everywhere, the liquid exert the pressure. So that's the meaning of liquids exert sideways pressure. It is not only top, it is sideways pressure. Yes, yes, Gauri.
Ma'am, what is density?
Density is mass per unit volume. That means what is the mass of the liquid in a bottle and how much volume. If you divide the mass with the volume of the thing, we will get density. Or to understand, that is mathematical formula. Otherwise, you can just say in understanding way heaviness or thickness. Okay, like water. Water is high denser, means it is more heavier than oil. Understood?
Okay.
Yeah. And actually, density you will be learning 9th standard. Density also you can calculate by mass by volume. Suppose there is a mass of the liquid is 10 liter, 10 divided by 2 liter, you will get the density. So this is a higher, you will be learning in 9th standard. But otherwise, to understand now, you think only about heaviness. How much thick a liquid has. Okay, fine.
Okay.
Next. Okay, next. Liquid exerts sideways pressure. So you can see, look at the first picture. It's a rubber balloon. So you can see there's a test tube and we have fit a balloon over there. And just let us consider this is first picture, this is second picture, third picture, and fourth picture. Okay. In first and second picture, which will experience more pressure?
Second.
Second one. Why?
Because more water.
More water. Or that, what does it mean? Height of the liquid column is more. Yes. Okay, more density also. When there is amount of liquid is a more density. Okay. Shall we now think about third one? Look at the third one. Third one, what is that? You can see in this third picture, the rubber and the pipe is fitted on sideways. Now, is that, what is the condition of the rubber balloon? Is it bulged or it is not bulging?
It's bulge.
Bulged. Why does this balloon bulged there?
Liquid goes inside the
Liquid goes, this liquid is flow to this pipe and it is exerting pressure on the rubber. Okay, so that means some part of the water must have entered in that. I know you must have played, while you were in the school 2 years back. You fill in the water and you throw one another, correct? So that's it. So that is an example of liquid pressure and you get pain, correct?
Yes,
If you throw water filled in the balloon at a one person, you will get a pain, severe pain, correct? So the reason is that why balloon is very low denser material. Balloon has not much density, but inside there is water has more density. But will you feel the same pain when you feel the air inside the balloon? No. Why? Because air is less denser than water. Okay, so that's it. Okay, so that is, so this picture shows liquid exert sideways also pressure. The balloon was sideways, so it exert the pressure on sideways. Now go to the fourth point. That is the example for fifth one. The picture of fourth picture is what we showing. Fifth point. An external pressure applied on a liquid in a closed container is transmitted uniformly throughout the liquid. What does it mean uniformly? What does it mean uniformly? I have
Equally.
equally. The school has a uniform. Everyone is equally. What does it mean? So if you look at these 3 points in the fourth picture, is liquid column at all the 3 points are same?
Yes.
Yes. So what does it mean? If
Equal amount of pressure.
equal amount of pressure will be acting on a object which is placed at equal depth. Okay. Suppose you have 3 people at the same level. A, B, C are 3 children inside the swimming pool at the same height. And all 3 equally experience the pressure. So that is the meaning of the 5th point. An external pressure applied on a liquid in a closed container is transmitted uniformly throughout the liquid. What is closed container? This will applicable when the bottle is more closed. Otherwise, what will happen when you go to higher classes? When you, if you look at the water here, suppose the container is on, there is a there is also is a air pressure also is there. Liquid pressure also is there. Air pressure also is there. That's why. Okay. So that's why it is specified closed container. That is the reason why could we break a plastic bottle. You crush the plastic bottle, you can throw it very easily. Why? Yes.
When we open 7 Up and all, we read gas.
Gas is escaping out of it because already there is a carbolic acid inside. 7-Up, Coca-Cola, Pepsi, actually what is it is included, it's a chemical solution, it's a carbolic acid. Carbolic acid mixed with the water and they put sugar into it and some flavor, lemon flavor or Miranda. It is, don't think Miranda is a pure mango juice. It is actually mango flavor. It's a chemical substance, you can make it. Mango, apple, a fizz. Don't think fizz is a purely pure soda. Fizz is not purely made from apple. No, they use some kind of chemical apple flavor into it. So that's why doctors are telling that don't have more Coca-Cola and other cool drinks because it will affect you internally because it is an acid mixed with carbon, oxygen and hydrogen. Carbon, you know, it's not good. It is good for our body for some extent, but it is not good for many purposes. Did you get that one? You can drink, not daily, especially babies. Small babies and all, you should not give this Coca-Cola, 7-Up and all. Why? Their bones started decaying. So they will not grow very fast. Okay. Once you become adult, if you drink once or twice, thrice in a week, it may not affect. But when you are a small, your digestive system, everything's very sensitive. So it can be a problem. Okay, children. So I think all the 5 points are over. So this is the thing, deeper into liquid, and this is the same thing. More dense the liquid, the higher the pressure. Okay, that is leave it. So you can show the oil and the water. I have asked you, who is having more denser? You said water is more denser. You can see the oil is flowing how, the water is flowing how. So this is some pictures. Okay, so that is the 5 points. And next, 6th point. 6th point relating to fluid pressure. It is not only liquid, it can applicable for the air also, air gases. Whatever the shape or width, the pressure at any particular depth is the same. So it does not depend upon shape of the container. If you look at this picture, A, B, C, D, these are the different shapes of container fitted with the pipe. And all the container, you can see the amount of water level is same. Correct? See. So, if you look at that, if you think about A, B, C, D, whether the shape is there, A, B, C, D experience the same amount of pressure. So, whatever the shape or width, the pressure at any particular depth is the same.
Ma'am,
Yes?
but more water is in serum.
Water is same, but the problem is height of the liquid column you look at.
Everything is same.
Height of the liquid column same. Correct. For example, if this height is little more and if there is more water here, naturally, it may not experience that same depth. So here more liquid column. So if you look at what is the condition of the water, you see empty tank. You are filling the tank with the water. So naturally, till where that water will remain in the tank till it full. Correct? Okay.
Yes,
So even just think all these three we did not have the water at all. Only this is having the water. Now you open this tank. Naturally, what will happen? All the water will be get into here, here, here till what time? Till the level of the water in everywhere is the same. Okay, so till even the shape is different, but the everywhere it will fill in the same. That's why we are saying the fluid can flow or take any shape of the container. It doesn't have that much intermolecular force is very less as we compare to solid. Intermolecular force means the force of attraction between the particles in the water. Solid is more, intermolecular force is more, while in liquid and gases it is very loose. So this is what pressure doesn't depend of the shape of the container. Okay? Yes. So we are coming to now end of the chapter, atmospheric pressure. Already we spoke whatever happened to the liquid, the same thing happened to it. Okay. Okay, one thing I ask you, as you go higher and higher, there will be air? Air is more or less?
less.
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 What is the reason for it?
Because air is dense.
Air is dense. Is that the reason?
Atmosphere.
Yes.
Air is
And
less.
we are going high, so the air become less.
Air become less because our earth is surrounded by air only at a particular height. Beyond that, there is no atmosphere. That's the reason that we cannot live in Mars or Moon or any other planet, because only Earth has got the envelope of the air. Now, recent study said Mars has 38% of air of Earth. Earth's 38% we have in the Mars. That's why they are looking forward of living on the Mars. Correct? Okay. So Earth has only particular height. Afterward, there is no atmosphere. So atmosphere is the layer of the air enveloping the Earth. So how much kilometer it has? Only 1,000 kilometer. From the Earth surface, if you measure 1,000 kilometer, beyond that, there is no air. So as you go higher and higher, what happen? Air getting decrease. Okay, air getting decreasing. So when you go to a mountain, then what will happen to the air pressure? Is it height of the air?
And
Air
because
will
of
be
the
less.
altitude, air become less.
So height of the air column is less when you go higher and higher. So in higher mountain area, there is less pressure. So this is the reason mountaineer, those who go to Mount Everest, everyone did not succeed in climbing the Mount Everest. It is the topest or tallest mountain in the universe. But no one, everyone who went before Tenzing Hillary, so many went, but all did not succeed. Only few people succeeded. There is a lot of reason behind it. Physically, psychologically, there's a science. So when you go to higher and higher, what happened? The air is less. So why? That is the reason they carry a special jacket of oxygen cylinder. Correct? They carry a special jacket and also carry the oxygen cylinder. Okay. Amal, are you there? Amal, are you there? Okay. Can you tell Amal, when you go to higher on the mountain, the people mountaineer, their nose starts bleeding. What will be the reason for it?
They will not be getting oxygen.
They won't get oxygen. So what will happen to the blood pressure, Amal? Air pressure is less. So what happened to the blood pressure inside our body?
It decreases.
Blood pressure is decreasing or air pressure is decreasing?
Ma'am, the blood pressure increases.
Yes. Yes. Now you are sitting at in your particular place comfortably. Anyone is a high BP?
No.
No. Anyone has low BP? That is possible because some of you are just cautious about your body structure. They may not eat properly. No, Gauri? And there's a possible you get high BP, you fell down. So, not high BP, low BP. So, now you are at a particular nicely sitting, no problem. You don't have no pressure problem. The reason is that your blood pressure, which is exerting you from inside, pulling your body, at the same time, air pressure is pushing opposite side. So unbalanced force, equal and opposite forces pushing one another. So how much blood pressure a normal human being have? In physics, it is 1 lakh Pascal. So atmospheric pressure at a normal temperature, 1 lakh Pascal. So 1 lakh Pascal air pressure is pushing you from outside. In the same way, 1 lakh blood pressure is pushing inside. When both of them are equal and opposite, they cancel each other and you are becoming a balanced person. Okay. So as you go higher and higher, as you grow old, what happened? Maybe some of your grandmother have high BP, low BP, no? Okay. Some people say the sickness or diseases of the rich people is blood pressure and sugar. It's not like that. Now everyone is getting, okay. So usually we used to tease like that. Okay.
Ma'am, will it always remain cancel and be 0?
If you are a normally healthy, you are a healthy person, it is always remain. Okay. But as I said, when you go to deeper into the sea or you go to higher in the altitude, then there is a variation comes due to what? Because of variation in the air pressure and liquid pressure. Correct. So when you go higher and higher, air pressure reduces. So it will be less than 100 lakh. Then who will have more blood pressure? Our blood pressure still remain 1 lakh. Correct. But air pressure reduces less than 1 lakh. So that's the reason when you go to higher, what happened? When blood pressure
Breathing.
increases, what happens
Small
to your
nerves break.
your blood vessel rupture or you get brain hemorrhage. As a result, the person start bleeding. The nose starts bleeding. The bleeding will come through mouth. Okay? Okay. So I think it's up time now. We wind up. We continue the lesson. Few more things and application I need to discuss. We will discuss in the next week. Okay? So start studying. Exam on the way. Okay? I did not complete this topic. We need to talk a little more. Okay?
Okay, ma'am.
Okay, children. Bye.
Thank you, ma'am.
Bye, children.
Thank you.
Yes.
Ma'am,
Complete your activity, PPT
ma'am,
fast.
this is not my activity.
Yes, those who got, I have noted down. Next week, when you come to the class, I'll give you how many send it, how many do not send. So I am giving one more week to complete it. Okay? Okay. Thank you.